campfire and thrown in an ad or a catalog printed on glossy paper and the fire turns a bright green color? Or have you ever wondered what makes so many different colored fireworks? Today we're going to learn about how different elements produce different colors when burned. So we've already studied atoms and their base structure. Remember that an atom is made of positively charged nuclei surrounded by negatively charged electrons that orbit around the nuclei in a fashion similar to how planets orbit the sun. The number of electrons each element has is shown in each element's box on the periodic table. Here, for the iron example at the top, we see that it has an atomic number of 26. That means that iron has 26 electrons. In an atom's natural state, the electrons relax into orbitals that leave the atom in the lowest possible energy state, and this is known as its ground state. When atoms are placed into a flame, the electrons are excited by heat, and they absorb energy from the flame. It continues to absorb this energy until it's too great for the electron to contain, and then the electron jumps into our orbitals that are farther away from the nuclei. The electrons can't contain this distance from the nuclei, and so they drop back down to their base state. And while the electrons fall, they release the absorbed energy. This energy is emitted as photons, or particles of light. The color of light emitted depends on the amount of energy the photons emitted. If electrons only go up one orbital, as you can see in the red one, it's only going from the second to third orbital. It's going to release a smaller amount of energy than it's pushed up 3 orbitals, as you can see on the dark blue that goes from the second to the 5th orbital. As we can see, red light is emitted by the lowest levels of energy. And as the energy increases, you move up through the rainbow until you hit purple light, which is emitted by the highest levels of energy. So make note that energy and wavelengths are inversely related. As the energy goes up, the wavelength goes down. As we can see in this poster, the different elements are going to show different colors when they burn. Sodium's going to burn a bright yellow, lithium a deep red, potassium's purple, calcium will burn orange, strontium is going to burn a light red, barium a light green, and copper burns a very dark green. So based on these colors, we can actually guess how far the electrons are having to travel, how many orbitals up, in order to make that color.
For this lab, you will need to get into groups of 2 to 3. As a group, you will have to determine what each unknown is based on the color of the flames. Make sure you write your observations down in the table provided. First, dip the popsicle stick in water. Then dip it into unknown number 1. Dim the lights and place the popsicle stick into a flame. Write your observations in your notes. You will follow the same steps for the other 4 unknowns. Once you have done all 5, compare your observations with your notes and decide which unknown is what. You have completed the video. Please take the post quiz by clicking on the link. Good luck!